Dear students, today we shall discuss Coimbu University BSc 3rd semester Geometrical Optics Session 5. Myself Dr. Niranjana A.R., Assistant Professor of Physics. Today we shall discuss achromatization of lenses not in contact and in contact. First, we shall understand the term achromatic lenses. Using a suitable combination of two or more lenses of different materials, the chromatic aberration can be minimized. A combination of two lenses is called an achromatic combination, an achromat, or an achromatic doublet. In practice, it is possible to correct the chromatic aberration for only two colors. The achromatism would be ideal if the images of different colors are formed in the same position and are of the same size. Thus, the longitudinal and lateral chromatic aberrations being totally eliminated. With a convex lens, the violet rays of light come to focus at a point nearer the lens, and with a concave lens and a converging incident beam of light, the red rays of light meet the axis at a point nearer the lens. Hence, to have an achromatic combination of two lenses, one of the lenses should be convex of crown glass and the other concave of flint glass. Therefore, an achromatic doublet is made using two thin lenses, a convex lens of crown glass of smaller focal length and a concave lens of flint glass of larger focal length. Condition for achromatism of two thin lenses placed in contact. An achromat is made by placing in contact lenses of different materials and of suitable focal lengths, such that the focal length of the combination is the same for both the extreme colors. The focal length of the achromat is independent of the refractive index. Let the lenses of the doublet have mean focal lengths f and f dash and mean refractive indices of their materials mu and mu dash respectively. See the diagram. One lens is made of crown glass, other lens is made of flint glass. FV, FR, R1, R2, R1 dash, R2 dash, mu V, mu R, mu dash V, mu dash R, F dash V, F dash R. And omega by F is equal to minus omega dash by F dash is equal to minus F omega dash by omega. Since omega and omega dash are positive quantities, F dash is negative if F is positive. That is, if the crown glass lens is convex, then the flint glass lens is concave. The ratio of the dispersive powers of the materials of the lenses is equal to the ratio of the focal length of the two lenses. Achromatization of two thin lenses not in contact. This is a derivation. If the two lenses are of the same material, their achromatic combination is possible only if they are separated by a finite distance. Consider two lenses L1 and L2. X is equal to f1 plus f2 by 2. Let f1 and f2 be the focal lengths of the two lenses placed coaxial and separated by a distance. See the figure. The mean focal length capital F of the combination is given by 1 by capital F is equal to 1 by small f1 plus 1 by small f2 minus x by f1 f2. Differentiating, we get delta f by f square minus is equal to minus delta f1 by f1 square minus delta f2 by f2 square minus x by f2 times minus delta f1 by f1 square minus x by f1 delta f2 by f2 square with a minus sign. Call that equation 1. From the previous equation which we have learnt in the previous sessions, minus delta f1 by f1 square is equal to omega 1 by f1 and minus delta f2 by f2 square is equal to omega 2 by f2, where omega 1 and omega 2 are the dispersive powers of the first and second lens respectively. Putting in equation 1, we get minus delta f by f square is equal to omega 1 by f1 plus omega 2 by f2 minus x by f2 times omega 1 by f1 minus x by f1 times omega 2 by f2, or minus delta f by f square is equal to omega 1 f2 plus omega 2 f1 by f1 f2 minus x times omega 1 plus omega 2 by f1 f2. For an achromatic combination, f should be the same for violet and red colors. Therefore, change in f must be 0, that is, delta f is equal to 0. Therefore, omega 1 f2 plus omega 2 f1 by f1 f2 minus x times omega 1 plus omega 2 by f1 f2 is equal to 0. That is, omega 1 f2 plus omega 2 f1 minus x times omega 1 plus omega 2 is equal to 0, or x is equal to omega 1 f2 plus omega 2 f1 by omega 1 plus omega 2. Call that equation 2. When the two lenses are of the same material, omega 1 is equal to omega 2, then equation 2 becomes x is equal to f1 plus f2 by 2. Thus, the condition for achromatism of two thin coaxial lenses made of same material and separated by a distance is that the distance between the two lenses must be equal to the mean focal length of the two lenses. Let us study one multiple choice question. Two lenses are made of the same material. To achieve achromatization, we should place them: option 1 in contact, option 2 at a finite distance apart, option 3 in any way, option 4 none of these. The answer is option B, at a finite distance apart. References: Optics by Ajoy K. Ghatak, 6th edition, TMH Publishers. Second reference, Textbook of Optics, revised edition for BSc classes as per UGC model syllabus. Authors N. Subramaniam, Brijlal and M. Avadhanulu. Third reference is an internet link as shown in the PowerPoint slide. Thank you one and all.